Hi, this is Mr. Erlin. Welcome back. We're going to talk now about solving some problems in trigonometry that use the phrase angle of elevation. What the angle of elevation means is that if we visualize the level of the ground, then we elevate our view from that perspective so that we're looking up. This would be the angle of elevation. Similarly, if we were looking from this perspective, from the ground level, and we were to reduce our gaze, in other words, look down, then this would be the angle of depression. So it's always relative to the horizon, which is assumed to be just flat and horizontal. What we'll see is problems like, for example, you've got a balloon floating in the sky and Johnny is looking at the balloon with an angle of elevation of 30 degrees. If the balloon is exactly 100 feet off the ground, how far is Johnny from the base of the balloon? And so you'd have to somehow find a way to build the right triangle conceptually. And what we're looking for is how far Johnny is from the space underneath the balloon. So this is our x. They tell us that it's flying at 100 feet in the air. And the angle of elevation, I don't remember what I said, did I say 30? So 32 degrees. It's that angle there. Once you set it up like this, it's really pretty easy to do. Relative to this angle, this is my eyeball. I've got my opposite side. I've got my adjacent side. Therefore, I'm going to use opposite and adjacent, which is our tangent. So I'd say that the tangent of the angle, no, that's confusing. Tangent of 32 is equal to the opposite over x. In this case, to solve this, I'd want to treat this as a proportion and cross multiply. X times tan 32 equals 100. And I ask myself, what's being done to x right now? Well, it's being multiplied by the tangent of 32. The way I undo that is I divide. So I'm going to divide by tan 32, and if I do it to one side, I have to do it to the other side. So then x is exactly 100 divided by the tan of 32, which is approximately, using my calculator, 160.033. I'd want to round to 100, so I'd say 160.03 feet. Now, that's the basics of this. Oftentimes, they'll throw in a little trick. Like, for example, in this case, I assumed that the 100 feet went from the horizontal viewpoint of Johnny up to the balloon. But I neglected to take into account Johnny's height. So, for example, had they presented this problem and been really specific about it, what they would have said was that this was 100 feet, which means that we have to subtract Johnny's height from that 100 feet. So really, if his whole length is 100 feet and Johnny's, well, let's make him 6 feet tall, that means that this length was only 94 feet. So within my right triangle, I would have had to say that the tangent of 32 is equal to 94 over x. Still cross multiply, still divide, and I get that x is equal to 94 over tan 32, which would give us a slightly different answer, 152.03. Can also be used with something called an angle of depression. And so, for instance, here's Johnny. He's looking down from a building top to Maria, who's on another building top. And we know that the buildings are 50 feet apart, and Johnny's looking down with an angle of depression of 50 degrees. And the question is, how much taller is Johnny's building? So really what we're looking for is this x here, right? We're trying to find out what this value is. We know this is a right angle, and if this distance between the building is 50 feet, then so is this distance between the building. But where does the angle of depression of 50 degrees go? Most times people would assume it goes here. But remember that angle of depression means relative to the horizon, it drops. So we're looking for that type of angle. So if Johnny were to look straight out at the horizon, he'd find that 50 degrees is right there. Therefore, we can think of two ways to bring it into the triangle. One is we can remember our parallel lines cut by a transversal. This angle and this angle are alternate interior angles. Therefore, this is also 50 degrees. Or we could have recognized that if this is perpendicular, it's a right triangle, then this is 90 degrees. And since this line is parallel to this line, we can assume that this is also 90 degrees. Therefore, of the 90 degrees, we've used up 50 degrees for the angle of depression, so the angle inside the triangle here is 40 degrees. And that gives us our triangle that we're going to work with. Because really, we don't care about this whole picture. What we care about is this triangle. I'm going to use the 40 up there, although you're welcome to use the 50 down there. All right, so now I'm going to say, all right, I'm trying to solve this with trig now. Relative to this perspective, here's my angle. This is my opposite side. This is my adjacent side. Therefore, I'm using opposite and adjacent. That tells me I'm using tangent. So I'm going to say that the tangent of 40 degrees is equal to 50 over x, opposite over adjacent. And then I'm going to treat it as a proportion and solve it. X times tan 40 is equal to 50. I'm going to recognize that I want to solve for x and it's being multiplied by tangent of 40. So I need to get rid of it by divide by that same tangent of 40. I'll do it on the other side as well. These cancel, leaving me with x is exactly equal to 50 over tan 40. And I can then use my calculator to make a decimal approximation from that, which is 59.58767963. I'd only want to look at it from the nearest hundredth, so I'd say x is approximately equal to 59.5. That 7 makes the 8 round up, 5.9. And that would be how much taller Johnny's building is than Maria's building. Thank you.